Hello friends, today we are going to solve walking robot simulation problem, which is a medium problem in yesterday's lead code POTD. So the problem says a robot on an infinity xy plane starts at a point 0, 0 facing north. The robot can receive a sequence of these three possible types of commands. One is -2, -1 and an integer k. So -2 says turn left 90 degrees and -1 says turn right 90 degrees and letter K, I mean number K says move forward K units, one unit at a time. Okay, we have to move K units whenever we receive a K, whenever we receive a command K. Okay, some of the grid squares are obstacles. The ith obstacle is at a grid point. Obstacle I is equal to xi comma y, and we have some obstacles array. Okay, if the robot runs into an obstacle, then it will instead stay in its current location and move on to the next command. So it will stay in current location and move on to the next command whenever an obstacle is occurred when the robot moves. Return the maximum Euclidean distance that the robot ever gets from the origin squared. So that means 5 is equal to 5 square. Where that means the formula for maximum Euclidean distance is the root of x square plus y square. So here this squared actually cancel the root. So we just have to return x square plus y square to this sum. Okay. North means y plus y direction, east means plus x, and south means -1. Okay. And yes, this is our problem. 4 -1 3. Let's try to understand the intuition for this problem. Okay. Oh, that's paint. Yes. So let's imagine this is the north direction, this is south, this is east, and this is west. Okay, and the robot exactly stands in this position. So which is nothing but f0 comma 0. Oh, sorry, this is 0. Okay, it stands at 0 comma 0 position and it can move according to the commands. So what are the commands? So 4 -1 3, 4 -1 3, 4 and -1 3. So for fourth, 4 is nothing but k. So whenever we receive k, we have to move k 1 unit places. So the 1 2 3 4. Okay, so here I'm here exactly, and -1 says that we have to move 90 degrees right turn, 90 degrees right turn. Okay, so 90 degrees right turn. So I mean the facing of the robot initially towards the north, right? So now that face has to be turned into east, as we have to move 90 degrees to the left, to the right. Okay, I think for robot right is this direction. Let's see, -2 turn 90 degrees left to 90 degrees. So for left and for right. Okay, okay, now we are 90 degrees move right direction, and then 3 units. We have to go 3 units. One, okay, 1 2 and 3. So now we are here. So the x is 3 and the y is 4. So total distance is 3 square plus 9 square. 3 square plus I mean 8 4 square. So sorry, this is 4. Okay, 4 square. Let's use 9 plus 16. So the nothing but 25 is our answer. S 25 is the answer. So this is the intuition. This is how we uh, how to done a process not to get the Euclidean distance for the commands of the user. So let's try to understand exactly what we have to do. We have commands and we have to move with respect to that commands. Initially, he says the robot exactly face towards the north. How we know it is the north? Say how we know it is the north. So we have to put some value uh, in that place. So of our identification of yes, this is the north direction, this is south direction. So for that, I'm saying so 0 is the north and 1 is the east. So goes in anti-clockwise direction. I mean, and 2. I'm sorry. So it's a clockwise direction and 3. Okay. So when we have 0, so it is north, and when we have 1, it is east, and when we have 2, it is south, and when we have 3, it is west. Okay, and then so these north pair exactly we have I mean in a graph we have 2 points in order to represent the position of an element. So it is nothing but in xy plane we call that as xi comma yi, right? So here north position element also have uh, that point not to represent as this is the north point. So that is what 0 comma 1. If n is 0 comma 1, then south is 0 comma minus 1, and east gonna be 1 comma 0, and west is 0 comma I mean minus 1 comma 0, quite opposite to the east, right? So yes, this is a representation. I mean, yeah, it changes. So up to now we understanding. Okay, north has 0 comma I mean minus sorry 0 comma 1 position north, and south has 0 comma minus 1. We can say that okay, in y-axis only y-axis is have the value, x-axis is 0, and in x-axis have the value, and y-axis I mean this is east, right? So x-axis represent the east and minus x-axis represent the west, so the value is minus 1 comma 0. Okay, uh, and the robot is exactly facing towards the north like this. Okay, and when we get the command, we have to move. If the command is -1, we have to rotate 90 degrees to the I mean left, and when we get -2, we have to rotate 90 degrees to the right. Yes, let's check the constraint again, conditions again. Yes, when you get the -2, 90 degrees to the left again, and -1, 90 degrees to the right again. So okay, this is the process, and in order to store the commands are in the integer form, and to get we need a data structure which performs the searching process very accurately, and uh, we have one data structure, actually two, which performs such operations big of n. One is a set and another one is a map, right? We can use either of these, that's not be a problem. And yes, that's it. This is the code. Let's try to understand this code. Yes, at first we created a set to get the elements in big of one-time complexity. So in order to check when we have whether we have an obstacle or not. So for that we need this set. So initially we have a vector of obstacles. So we just convert these obstacles which is in vector form into a set form. Okay, we're taking every obstacle of an obstacle and put that inside that into this set. So before that the set is an uh, string type. If you want we can make this as an entity type also, that's not a problem. So yes, in order to convert the integer type so into the string we can use to string function. Okay, and okay, now see obstacles, uh, the points where the robot have restricted to go. So this is x point and this is y point, that is here. So 0 represents the x point and y represents the y point. Okay, up to here I think you understand the code. And so this is the condition he said, the robot actually facing towards the north. So for that, so here two elements to represent, two elements are put together here. So I just put that into an object called tape, which is a director, I mean direction. So which is a pair type. Okay, and here x, y, these are all the I mean initializations of variables. So just try to understand the process what we have. So we are iterating the commands, and when we get the command -2, what we have to do, we have to move 90 degrees to the left, and when we get the command -1, we have to move 90 degrees to the right. Otherwise we have to move k steps forward in that direction where it is has to be, and then finally we return our a distance. So this is what happens how we are moving 90 degrees to the left. So here I say uh, north direction has a, in order to show this is a north direction, it has a point which is nothing but 0 comma 1. So when we perform 90 degrees to the right, so these 0 comma 1 actually represent into -1 comma 0. Understand? So when we perform mm, I mean 90 degrees to the right operation, we have to imagine this is x and this is y. So we have to convert the change the direction or modify the direction object into like how it changes. So here y element is minus of I mean x element is minus of y element of north, and y element is the x element of north. So this is how the operation performed. And when we perform the 90 degrees to the left operation, the x element is the y element of north direction, and the y element is the uh, x axis, I mean x coordinate of the north direction. Okay, just all they are alternating. Now for that we just write that in code from here -1 yeah, direction second element, and direction of I mean direction of and then direction of first element, isn't that right? -1 of direction of second element and -1 of direction of first element. This is the way to access the for the second element, and this is the way to access the first element of tree. You just have to use the dot operator here. So this is also same. So direction of second element and direction of first element. Why we have used -1 here? Because when and like continuously to 90 degrees right operation is performed, it actually facing is go to the north, and if 90 degrees to the right operation is performed, facing is towards the east, and again 90 degrees to the left operation is performed. Now the facing is towards the south, right? So the point 1 comma 0 can represent in 0 comma 1 also. So for that, the x coordinate of the east direction is the y coordinate of the south direction along with -1. Understand? And zeroth coordination of each direction is the zeroth coordination of the, I mean x coordinate of the south direction. So we just add minus to this 0. So there is no difference between the -0 or +0 in mathematics, right? So that is what we are using here. And when we get the command k, we just have to move k steps. For each step we are going into a new coordinate, right? So initially we are at 0 comma 0 coordinate, and when we move one step, so we get new x-axis and new y-axis, and another we get new axis and new y-axis. But every step, I mean, but in each step we have to make sure that it is not an abstract. If imagine this is an abstract, and we successfully move to here, and when we check here we know yes this is an obstacle, so we just have to stay here and go to the next command. If the next command is 90 degrees to the right, so face towards the 90 degrees to the right, make the face of the robot towards 90 degrees up to the right. So that's we are performing here. So we just find in the new coordinate is nothing but is the initial coordinate 0. So 0 is added to uh, new coordinate. Oh, what is new coordinate here? Yeah, if it is a 1 1, like we don't know what exactly whether it is a 1 or 2 or 3. It's depending upon the direction of the direction of the first, and y coordinate is depending upon the direction of the second. Understand? I mean, if it stays in the not it stays. I mean, the robot face towards uh, the north, and it moves uh, one step out of let's say 4 step. It has to move 4 steps in first example. So in first step, the robot I can understand. So it going to the new coordinates, and the coordinates are nothing but initial coordinates plus the new coordinates here. What pair of, I mean this is the object, right? So pair of uh, this is not direction. So in that not direction we are accessing the first coordinate. So pair of x. For y coordinate, initial coordinate of y plus pair of dot y. So then only we can access this element. So after so the access is like 0 comma 1 after performing one operation. Understand? And then we are checking that coordinate actually present in the set. If it is present in the set, it's an abstract. We just have to break this command and move on to the break this command means we are breaking this loop and move on to the next command. If the next command is then it may be either right shift, I mean right move, or left move to 90 degrees, or we get again k commands to move. If we get again k commands to move, we are again have to perform new directions, new x-axis and new y-axis. Okay. So if it is not present in that, so yes it is one of the axis we can, where we can move, we can freely perform the move operation. That means we get we have to change our old axis 0 comma 0 to the new axis which we get 0 comma 1. So that is the old axis. So as it moves clearly from this position to the this position, in order to move from this position to the something position, we have to track this, right? So initially we can say this is an origin. So we have to shift that origin to this current origin, and we can perform the move operation. If it is a valid, if it is not an abstract, otherwise we just have to go to the next command. So that's yeah, we are doing here. So this is a small one at the origin. So we shift that origin into the new axis. Understand? And when we completed this loop, we have the x value and y value. I mean, uh, for suppose, okay, it's going to take 20 minutes. So yes, I'm successfully performed the operation from here to here, and from here to here, and right shift. Okay, from here to here, and from here to here, and okay, this is an abstract game, so no need to go back and perform the operation. Okay, so there is okay. So next operation is like move towards down. So from facing is towards here and move here to here. And now my comments are over. So this is the last position which I get. So we just have to return the x square plus y square value, which is the Euclidean distance. So x square plus y square is nothing but the Euclidean distance. That's what we are doing. And that distance has to be maximum, right? So initially 0. I mean that distance uh, not can't be a negative. So for that, I'm taking it 0, and x square plus y square definitely is the maximum. It gives the maximum value. Uh, okay, and then finally return that maximum value. Wait. Yes, sure. So, okay, if you have any doubt, just put comment on this video. I'll try to explain. And I hope you understand this intuition. Once again, thank you guys.